Hey guys, what's up? So today I'll be teaching you guys limits in Calc. So Calc isn't really that hard. If a lot of you are taking it, it's not that hard. It's just a lot of memorization. So you gotta memorize a lot of things. Limits is actually one of the big units in Calc. So I'm gonna show you guys just like the basics of it. If you're not already in Calc and you're gonna take Calc next year or in a couple years, always good to be ahead and know what to expect. So I'm gonna show you guys some rules for Calc for limits. So basically, the first one is special. Yeah, this is gonna be my hand right side. Special trig limits. So, yeah, special trig limits. Okay, that's the first one we're gonna do. So basically, special trig limits. You have your limit. So how you read this is you have limit, and then you have something below it, which is usually x and an arrow, and usually it's 0. It could be a different number. Which how you read that is what is a limit, and then you have an equation next to it. So for this one, you actually do like just like a regular equation, but I'm gonna do actually sine of x underneath x, and how you guys read this, it would be what is the limit of that of sine of x over x when x approaches 0. So let's say you have a different equation. Let's say you have like 3x minus 4. So what is the limit of 3x minus 4 when x is approaching 0? That is how you guys would read this. And this is a special trig limit. So basically, this is always going to equal 1. That's what you want to get. You want to get this to equal 1. You always want to get like this. So these two have to be the same number. Remember that. So let's say you have these two. You want to, like, when you're using like sine, cosine, tangent, you want to get the two of the same numbers, and then automatically that will give you 1. That is just one of the rules. So the second one is you want to have a limit. Obviously, you're dealing with limits as x is approaching 0, and you want to have it's basically the opposite. You want to have x over sine x, and this will also give you 1. And your third one is not gonna give you 1. So if you memorize these are gonna be really good. Which is basically your limit, and your as h approaches 0, we have 1 minus the cosine of x over x. Yes, over x. And this one actually will give you 0. So as long as you're in this formation or format, you actually could. That's where the format you want to get to, because that's the answer to these. So the calc is kind of like way to give you an equation, and you're supposed to like put it into a certain form or get it to where you could recognize it. You could put numbers in, plug numbers in, and that's all kind of calc stuff. It's kind of like algebra, but it's like more complex algebra, and it's just a lot more steps involved that you gotta like memorize. But the math itself, the algebra itself, is not complicated. I mean, I'm better at algebra than geometry, but if you're not more of an algebra person, it's gonna be a little harder for you. But like algebra, when you plug in factors and numbers and all that kind of stuff, you're factoring, your span, you're reducing. It's basically what limits for calc is. So you have functions, okay, and you're gonna see something called continuous. You want to make sure the function, I'm not sure if I'm spelling this right, is continuous. How do you know if it's continuous? You basically have 3 steps. You have your f of c, which is your f of your number. So it should be f of c must be valid or must be defined. So you want to have your f of c defined, and okay, so this is defined. Okay, number 2 is you want to have your limit. So we're going to use example limit when h approaches c, and you want that must exist. So limits, guys, you basically have of a graph. If you want to do a limit of a graph, you have your left of the graph, your right of the graph, and you basically have to meet in the middle, kind of. You have to meet in the same, not in the middle, but you have to meet where like the line crosses or intersects, or like where they both meet. If your left and your right limit do not match, then the limit is not valid. You do not have a limit. So if you have two different, one limit 4, let's say limit from the left side is 4, limit from the right, left side is 4, limit from the right side is 5. There's no limit. They both have to match. So they both have to be the same number from the left and the right. And your third step to make sure the limit for the function to be continuous is you want f of c, which we just said in step 1, must equal your limit, which we said in step 2. So that is how you tell if something is continuous as h approaches c. Okay, and the third thing I want to talk about is 0, 0. You see a lot of in calc for limits. So what does 0, 0 mean? So when you get like let's say you get, okay, I'm going to do an example. 3x minus 4, and you want to find a limit. The question is, find a limit as h approaches, let's say 1. What you want to do is actually just plug in 1 for h. So you have 3, and then you want to have 1 minus 4. So it'll be 3 times 1, 3, minus 4, which will give you negative 1. So that right there is your limit, which is negative 1. So that's your limit, which is negative 1. So if you do get 0, so let's say let's say like it's, let's say your limit is, okay, so I'm going to do another example. So you have 4, and you have, you have 4x, plus 8. Final limit as, it's going to be as h approaches 2. So you plug in 2 for h, 4 times 2. I'm going to do actually a fraction, over 8. I could do 0, because anything over 0 should be 0. Would be 0. But I could just do, you know what I'm going to do? Okay, so we're going to do 4x minus 8 over, I'll say, 2x minus 4. You want to find the limit of this when x approaches 2. So you want to plug it in. 4, and you have 2 right here. So 2, 4 times 2, 8, minus 8 is 0. 2 times, plug in 2. 2 times 2 is 4, right? These two right here. These two right here. 4. 4 minus 4 is 0. So you get 0 over 0. That means you have to do more work. So when you see 0, 0, more work. So when you have to do more work, when you see, usually we'll get 0, 0. There's 4 steps you can do. So when you get 0, 0, step number 1 is factor and divide out. So you're choosing one of these steps. Depending on the problem you have, you're choosing one of these steps. So if you could factor out, if you could factor and divide out, you want to do this. That's just step 1. So I'm going to do 4 steps, but basically you choose one of these steps. Depending on your equation, you're going to do one of these steps. You're either going to factor and divide. You're going to rationalize the denominator. So rationalize. I'm going to say denominator as DE. They also, they shorten stuff out in Calc. And that's in a lot of classes too. Like even like in any college class, they're gonna shorten stuff up. I can't think of it right now. I'm tired. So basically, instead of saying like, example, you just boot EX, and it just makes it shorter and makes it like you got note, and it makes it quicker. That's what a lot of teachers would do. But yeah. So rationalize the divide. So the first step is factor and divide out. Second step is rationalize the radical. Third step is simplify complex fraction. So if you have a complex fraction, which is like a fraction over another fraction, so you have a fraction and then over another fraction. So that means you're going to you want to simplify the complex fraction. So simplify complex fraction. Okay, complex fraction. Okay, just like that. So I'm just gonna do an example. X minus 3, x plus 5. Over, and then x minus 7, or x minus 6, x minus 2. So you have a fraction over another fraction. Okay? So that's a complex fraction. And the fourth one thing that you can do is multiply to, or multiply and, whatever you want to do, and expand. So multiply, I'm going to say 2. Multiply to expand. So you want to, I don't know how to multiply this span. So let's say you have like x squared, I don't know, plus 6x plus 9. So you just do this. So you want to times get 9, and you want to plus. No, you want times get 6 and plus get 9. So let me 9x plus 6. So times get 6. Plus to get 9. Okay, I'm making this more confused. So it'd be like x plus 3 and then x plus 3. So, yeah, so it would be plus for 6. So then it would be like this. And that's how you do it. X plus, so when you factor them, you would actually get this one right here. So you basically have x squared plus 9x plus 6. So you do whatever times will give you, I think it's this one, and then plus will give you that one. It could be opposite. So it would be it'll be 3 times 3, 9, and then you have plus it, and you get 6. So that's for that one. Another one, especially you will learn this in pre-calc and probably even like lower than pre-calc, is the VA, which is a vertical asymptote. You guys probably heard that a lot. To find that, all you would do is you want to set your denominator, which I'm going to say DENOM, short for denominator, set that equal to 0. So an example would be, doesn't matter what your numerator is, so we have a fraction, we have x plus 5 and x plus 2. To get the VA, which is the vertical asymptote, you're just looking at this, you don't looking at that. So it'll be x plus 2, you set that to 0, you minus 2 on each side, it will be h equals -2. And that is your VA, just like that. Okay, the next thing I'll talk about is finding discontinuities and non-removables. So, for discontinuities and removables, you have 6 steps, I like to call it. Okay? For discontinuities and non-removables, the first step is, this is what you have to do in order, so you have to do this in order, is factor or span, depending on the problem you have. Okay? The second step you want to do is to set the nom to equal to 0. Set the nom equal to 0. Third step is simplify your function. So I'm going to say simplify function. Your fourth step you want to do is find your limit based on your previous problems. So find lim on, or based on, pre-probs. Okay? So I could do an example with you. I just want to get the rules out there. I could do another video if you guys are really interested. This probably bores the crap out of you, but this is what we apparently need to know for calc. Not that I'll probably use this math the rest of my life, but the thinking behind all this is a good skill to have, definitely. So the fifth step is you want to find a limit from the left and the right. So let's say you have limit of x approaches 6 or whatever, and it's a negative. That negative right there is basically, it means it's coming from the left side of the graph. Okay? And if you do have go back one time, a positive, that's coming from the right side of the graph. So you want to find, the fifth step would be to find the limit from the left and the right side of the graph. And that will give you actually negative or positive infinity. It's a lot different when you show you the work from explaining it. And then your sixth step is your results. So you basically have all your different results based on the work you got, and you can find your holes, your vertical asymptote, just different stuff. So that's that. That's basically everything you would need to know for, limits. I could do some problems with you guys. So I'm just going to do a couple. Let me choose what I want to do. So this is what I want to do. Okay, so you want to find a limit of x approaching 0. And make sure when you carry your work. Work is a big part in calc. Like my professor says, she grades us mostly for the work and not the answers. So you want to find a limit for sine of 3x. And we're going to go under 7x. So how you would do this for these problems is, like I said, the first step is what? Okay, you want to plug in 0 for x. Okay, so then we get sine 3 times 0, 7 times 0. So for these problems, it's going to give you 0 off 0, obviously. So for these problems with sine and that kind of stuff, find a limit for those, not numbers, you basically want to break up the equation. So you have sine 3x over 7x. You want to take out your numbers, okay? So we have sine 3x over 7x. The numbers you want to take out would be 3 and 7 because you want to take out your numbers. So you're basically taking out the numbers. It's still the same equation. So we're actually going to, all right, I'm going to go back. Okay, so on the bottom, look at the bottom. So you have your you have your thing up here, right? And now you want to take out the numbers. So it's still the same problem. So you have sine, we're going to leave it to sine x, going to take out 3 and 7, and you want to keep the x on the bottom, so x on the bottom, times 3/7. So the same thing, you're just taking out the 3 and the 7. So the same exact thing, leaving the x's, taking out 3 and 7. Okay, and basically, sine x over x is actually one of our rules, which equals 1. Now, I'd say that for cosine, the 1 minus cosine x over x, that will give you 0, I believe. It's not 10, it's 1 and 0. So for this, that'll give you 1, right? So this is 1. So you have 1 times 3/7, and the answer is 3/7. So your limit is 3/7. So you have your limit as x approaches 0. For that would give you 3/7. Okay, that's one of the problems. If you have a piecewise function, we could do, you know what, I'm gonna do a discontinuity problem. Okay, that's the one with the 6 steps. Yeah, you know what? Alright. You know what? I'm gonna do 2, 4 plus 1. Alright. Fine. We'll do this one. Okay, so this is a piecewise function. You have f of x equals piecewise, which you have something up here, so it'll be x squared. It's gonna be kind of hard to fit because I can't write small because I'm writing with my fingers. Minus 4x plus 2, and then the bottom would be negative x squared plus 4x minus 2. And then you have your rules for them. So this is x is less than 2, and this is x is greater than or equal to 2. So what we could do is actually like plug in something for it. So we should actually follow the rules. So like you want to plug in x for something that's less than 2, and for here it could be greater than or equal to 2. So you just plug in that value into x for both equations. You want to follow. These are like your rules. So like these things on the side, that thing on the right side is your rules, and these things on the left side, that's your function. So you want to plug in what the rules tell you. So it has to be a number less than 2 for this one, and then for this one it has to be a number greater than or equal to 2. You plug those numbers in for x, right? And then you would get, if you get your kind of like limit, I guess. So like if they're both the same answer, then you're good. If they're both different, then it would be DNE. And you see DNE a lot. It's not like unvariable or it doesn't work, it's unknown. DNE is it does not exist. So you see that a lot in Calc. That's a piecewise function. So let me see which one I could try this one with you guys. So f of x, I haven't really done this yet, just off my top of my head. Minus 7 x squared minus 49. So this is the question is if finding discontinuities. So basically what you want to do is the first step, which is factor dash span. So look at the top. Okay, what can we do with x minus 7? Nothing. Okay, down here, x squared minus 49. What is that? A perfect square? So you have x minus 7, x plus 7. Okay, parentheses that bad boy, and that is basically that. Okay, and then what the second step wants us to do is actually find the denominator for the bottom. Set the denominator equal to 0. So since we have 2 of them, 1, 2, we actually would set both of them up equal to 0. So x minus 7 equals 0, x plus 7 equals 0. So you basically get negative 7 and 7. So you send them to 0. So then you get 7 and negative 7. And you want to factor them. So then you have x minus 7, x minus 7. These will cancel out. You're left with x plus 7. So we found the denominator equal to 0. Okay. And we found, which is 7, negative 7. And we crossed them 2 out, which actually leave us with x. And I think I crossed out x minus 7. Yes. So it would be x plus 7. So now what they want us to do is the third step is to simplify, which we did. And they want us to find a limit. So now we have to find a limit for both of these down here. Okay. So you want to find a limit as x approaches 7. And you want to find a limit as... Can I erase? Cool. Okay. And then you want to find a limit as whatever. As x approaches, I'm fine. As x, okay, sorry, I'm messing up. So you want to find a limit as x approaches 7, and a limit as that's two different problems. It's not a fraction problem. It's just two different problems. As x approaches -7, and this bad boy is our function. I'm tired, and I'm still kind of learning this, but I don't know. I have a test on this tomorrow, so I thought making a video would get me to realize it more. Okay, so we have these two right here, okay? So you want to find a limit. So we want to plug in -7 for the bottom, and you want to plug in 7 for the top. What do you get for the top? You get 1, plug in for 7, that's all you're doing. 7 plus 7 is 14. The bottom would be -7 plus 7, which is 1 over 0. So you always have, like, one that's not, like, I guess, right? Which is the one that's under 0. So, like, the top one, I guess, would be, like, your removable, and the bottom one would be your non-removable, or opposite. I'm not really sure about that. So, basically, we found the limits, and now the only thing you want to do is actually find the limits from the left and the right to get negative infinity, and you want to get positive infinity. So, basically, what you want to do is do your limit from the left, your limit from the right. So, since we have 7 for the limit, it would be 114 and 10. Okay, so now you want to find a limit from the left and right. So from the limit as x approaches 7, negative. So it's not -7. It's just 7 as from the left side. Oops. And then we have a line, and we want to find a limit as x approaches 7 from the positive. And usually when approaches from the positive, approaches from the right is usually positive infinity. Approaches from the left is negative infinity. I'm gonna show you why. It's not always the case, but I'm gonna show you why. So, and we still have our function, which is 1 over x plus 7. Okay, so that's disgusting. That plus sign is disgusting. Okay. Plus, not too much better, but yeah, x plus 7. So we're not looking at the value. We're looking at if it's negative or positive. So you want to plug in 7. 7 plus 7, 14. So that's 1 over 14. What is that? Okay, 1 over 14 is 1 over 14. And they're both positive. Positive over positive equals a positive, which is just infinity. Positive infinity. You don't have to have the positive sign, but you can. Positive infinity. For negative, it would be 7 plus 7, which is 14, but it would be negative since it's negative at the bottom. So it would be plus over negative, which would give you negative, which would give you negative infinity. And there you go. From the left, as approaches 7 from the left, we get negative infinity. Approaches from the right, we get positive infinity. So that's how you guys do that. You want to value graphs, and there are functions. So you would have functions. So tables. So basically the tables, you just want to look at like the value that's like closest to like your limit. So if you have a limit of x approaches -2, right? X approaches -2, that's your limit. And you have like some kind of equation, like whatever, blah, 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 s cubed plus a, s plus 2, you do the math, plug in -2, blah, 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 you will get 0 over 0. That's not, okay, cool. So the table would be like negative, you want to get as close as you can, negative 2.001, it should be 2 zeros, 1. That is your x, and this is your f of x, which is your y. And then you have 12. Okay? Whatever. 12.00 if they want me to put it like that. And you have negative 1.99. 19999. And then you have 11.99. So you can see that these two are really close to 2, which our limit was -2. They're both really, really close to -2. And you gotta think about, these are really close numbers, but there's still so much numbers between these two. That's calc. But we're going to look at it as the answer to this one. It would be 12 because, I don't know, it's a full number. It's also close to 2. They're both, like, really close because, like, -2 is right between here. So it would be, like, these two would be really close. But for this one, the answer is x would be 12. And make sure you label your shit. Make sure you label your stuff, because if you put like x equals, if you put 2, like, no, you gotta put x equals 2, because you gotta label your stuff, because that's what my teacher told me. It kind of wraps up this video. You know what? I'm not gonna do that one. All right, so you do have a circle for trig, which is like, you have your circle, and then you have like each you have your circle, you have your circle, and then you have, I forgot what it's called, and you have like all your numbers on the outside, and you have like pi, you have like, it's like that. You got pi on that side, and then you have on the other side, 2 pi, and then pi right here. 2 pi, and you have 180 degrees, and then you have 0, 1. It's like I forgot what it's called, but there you have that. Okay, that's calc. You get that in pre-calc. So you use that to figure out sometimes what your limit is when you have like different limits. So I'm gonna do one last one with you. We're going to find a limit of. Yeah, fine. We'll find a limit of, as h approach. We'll find a limit of tan of pi x over 4. So limit of tan x, tan pi x over 4, as x approaches. You know what? X approaches 3. Sorry about that. And x approaches 3. So what you do is plug in 3 for x, right? So you plug in 3 right here, and you get actually, okay, tan, it'll be pi 3, but you just switch the order, so it'll be 3, it'll be 3 pi, okay, over 4. And then when you look on your pi circle, I forgot what it's called, your little circle, I forgot what it's called. What is it called? I don't know what it's called. Okay, when you look at your little circle, you could find 3 pi over 4, and then you get your x and y value, which is negative square root of 2 over 2, comma, square root of 2 over 2. And since it's tan, what tan is y over x. Okay? You have, it's also something to know. So you have tan 3, what am I doing? I can't do anything today, can I? Tan 3 pi 4 tan equals y over x. Okay? You have the other ones are what? Don't do that. Wait, why is it getting rid of all of it? Wait, come back. You could blame it all. Oh man. Okay, tan we have 3 pi over 4. Cosine is x. I'll get rid of all of it. And we have, what's your last one? Sine, which is y. And then you have, it's called, I think, the pie chart. I don't know what it's called. You have CSC, which is something I forgot. O equals 1 over sine x. And you have sec of x, which is 1 over cosine, and then you have cot, or cotangent, which is what that is called, which is 1 over tan of x. So we have tan of 3 pi over 4, which I said is, you get the x and y value. So basically all you're doing is tan. Tan is y over x. So you do y divided by x, which is square root of 2 over 2 divided by negative square root of 2 over 2. So if you want to divide, when you divide fractions, you actually divide, you do the first one, you switch it to times, and then you flip the second one. So it would actually be, so that's, okay, so you figure that out. So it would actually be square root of 2 over 2, and we go times, then we flip it, so it would be divided by negative square root of 2 over 2, but since we're times it, we could flip the second fraction. So then it would become 2 over square root of 2, and this is negative. So when you times them, you get this, that, and then that, and it's negative. Cancels, brings you to -1, and that is your answer. So that's just some calc stuff. I actually have a test on this tomorrow just want to give you guys a clue what to expect with Calc. It's a lot of memorization. It's, if you can memorize really well, you could do it. If you study for a lot, you can. I usually study for like barely, and when I do study, it's at the last second. But like, unless you have a perfect memory, you're not gonna do good unless you're just really good at math. Like, you gotta like take the time to study, and go over problems, test reviews, if you want to do good. And like, keep your notes really organized, because that's also really important. You want notes on the test. You want to keep everything organized, so you know what to study and know what to expect. And also they're gonna expect a lot from you since you're in Calc, because you complete all the maths, and Calc is pretty high in the math field. It's only up to Calc 3, I think, and that's like the last math probably the hardest math you ever do. But it's pretty hard, challenging, but if you like numbers, like math, it's fun. I mean, it's I would say fun, but it can be fun for you. It's something you could try. But thanks for watching this long video. I'll see you guys next one. Like, comment, subscribe, and peace.